Great. Well, welcome everybody. We are here today for yet another session of Raja and Neil's FASD book club. For those of you who aren't familiar yet, we are inviting the chapters and editors from this book. The details will be made available online later if you haven't seen it. But today we have Dr. Alan Price has come to talk about his chapter, which is focused on how our understanding of FASD has progressed. So Alan is going to introduce himself and he's going to give a quick overview, the 15-minute overview of everything that we've learned about FASD in the past 50 years. and then we'll stop the recording and we'll go into a Q&A. So Alan, I'm going to send it over to you.
Okay, great. So hi everyone, I'm Alan Price. I'm currently a lecturer at Liverpool John Moores University in the UK. I was previously at the University of Salford, where my research team is based, and I'm due to be starting back at Salford in September. And I'm going to be talking about my chapter. So this chapter is actually based on part of my PhD thesis. Raja was one of my PhD supervisors, and I'd written a sort of prologue to that on the history of FASD and an overview of some of the biological mechanisms of how prenatal alcohol can lead to FASD. And Raja thought it would make a nice introduction to the book. So together with Neil, we made a few small edits, but essentially it's the same as the introduction chapter to my thesis. So it begins with a history of FASD, which takes us all the way back to the Old Testament and the Book of Judges, which was written around 500 BC, and which features a warning shown here, quote, not to drink wine or strong drink. This is during a pregnancy. I'll come back to that in just a sec, because there's another quote here that's been attributed to Aristotle. This would be around 300 BC. Aristotle is supposed to have said that foolish, drunken, or harebrained women most often bring forth children like unto themselves, morose and feeble. So obviously written in some quite old-fashioned language there. However, and these quotes, you may see these quotes when reading around the history of FASD. However, neither of them seems to be a genuine warning around prenatal alcohol. So for the Bible quote, Bible scholars believe that this warning is not to do with the harm of prenatal alcohol. It's actually to do with religious rights, something about that baby being born in a certain group of within a certain religion. So that's more to do with sort of religious rules. And the Aristotle quote actually turns out to be a fake. It was apparently made up by a biographer of Aristotle written sometime in the 1600s. For the first real genuine written evidence of that alcohol can affect a pregnancy seems to come from the London gin epidemic, which is around the late 16 to early 1700s. There's a trade war going on between England and France, and it leads to a very cheap gin being widely available, and a massive increase in the consumption of gin, basically, and widespread public drunkenness, shown here in a 1751 print by William Hogarth. And around this time, doctors are suggesting that alcoholism is linked with birth defects and poor health in the children of alcoholic mothers. So I've got some quotes here. I won't read every single word, but half the train of chronic diseases with which we see children afflicted are only the secondary sighs and groanings of parental ill-spent life. Something about the debauchery of the mother. There's a lot of this language around debauchery and different classes of people. It's really quite very different from how we tend to write these days, but you can see that they're getting at this link. There's some kind of link here between the alcohol and the problems that they're seeing in infants at this time. What must become an infant who is conceived in gin, the poisonous distillations, spirituous liquors renders infants meager and sickly. So the people are starting to notice that there's some link between certainly heavy drinking and poor outcomes in infants. Then we move forward to around the turn of the 20th century, and what's really the first study of the effects of alcohol on pregnancy, and that's published in 1899 by W.C. Sullivan, who's a prison doctor. And he finds that there's a much greater risk of stillbirth and death in early childhood when the mother was an alcoholic compared to non-alcoholic mothers. He also notes here that mothers drinking had a greater effect than fathers drinking, so suggesting for the first time really that there's a direct effect of alcohol on the fetus that is the key mechanism going on here, rather than some other form of inheriting those words they were using like debauchery and things like that. There's actually a biological mechanism going on here, he's suggesting. Around this time, there's a general opposition to alcohol among certain groups, especially in America, related to the temperance movement. And you have prohibition of alcohol in the States around the 1920s. And there's a lot said during this time about the harms of alcohol. And some of it is quite exaggerated. Some of it is basically just propaganda. And so when prohibition ends in about 1933, so much has been said about the harms of alcohol, so much has been exaggerated about the harms of alcohol, that it sort of all gets thrown out, including a lot of the accurate stuff. So we've kind of thrown the baby out with the bathwater here, and the issue of prenatal alcohol exposure seems to get sort of forgotten. And it stays that way until around 1970, when a junior pediatrician named Christy Uleland, there she is, working on a maternity ward in Seattle, Washington, in the States, notices a similar range of birth defects in 8 infants, all of alcoholic mothers. Each of them has microcephaly, which is a small head and brain, stunted growth, developmental delay, short palpable fissures, which is eye openings, joint anomalies, and small jaws. And she writes this up in a paper. She writes that these observations indicate that infants of alcoholic mothers are at high risk for pre- and postnatal growth and developmental failure, and suggest that greater attention be given to alcoholic women during the childbearing years. And as I say in the chapter, this brief statement is arguably the true source of the modern investigation into the effects of prenatal alcohol exposure. Because remember, there's been studies done by this point, but everything gets forgotten after prohibition. So this is, in a way, is really the start of where we've come to today, and we have the Christy Uleland to thank for that. So Uleland's colleagues, David Smith and Kenneth Jones, then write a series of papers describing the effect of alcohol on the fetus, including this one in 1975, where they first coined the term fetal alcohol syndrome, or the fetal alcohol syndrome, as they call it then. Now, it actually turns out that a paper published in French in 1968 by a doctor called Paul Lemoine describes the same symptoms in, I think, around 200 babies of alcoholic mothers. So he kind of did get there first, but for whatever reason, maybe language, that paper doesn't really make an impact in the same way that the Jones and Smith papers do. So it's the Jones and Smith papers that really sort of get the ball rolling here. It's noted around this time that there is some skepticism at first, which I think you would probably expect from the medical and research communities. Alcohol is a commonly used substance after all. So they're saying, look, surely we would have noticed by now if alcohol was causing birth defects. Skepticism, I think, is appropriate in situations like this where something changes in such a profound way. But after the early 1970s, more and more evidence starts to pile up that shows quite convincingly that this is something that's happening. At this point in the chapter, I stop writing in chronological order and start to provide an overview of what we've learned about the mechanisms and some of the complexities around prenatal alcohol since the 1970s. So there's a concept in research called triangulation. which means that when different methods and results all point toward the same conclusion, then that conclusion is, is more likely to be true. And a lot of the research into the mechanisms of prenatal alcohol come from cell tissue studies, where we can observe the direct effect of alcohol on cells in the lab. Animal models, like mouse models, where we can randomly assign animals to certain conditions, like a prenatal alcohol condition, which we can't do in humans. Human epidemiological studies, where we look for patterns in the population, such as higher alcohol consumption and more severe developmental differences. And more recently, human brain imaging studies, where we can observe brain activity in real time during tasks. So the research into prenatal alcohol, fetal alcohol syndrome is diversifying. You've got different groups of people looking at different things and using different methods. And by the 1990s, we've come to the point where people are now talking about fetal alcohol spectrum disorder. So we've realized that there's a lot more to this than the miscarriages and the physical birth defects. And FASD is now being thought of as primarily a neurodevelopmental disorder, or rather a collection of related neurodevelopmental disorders at this time. We're also seeing by that stage in the 90s, government warnings to abstain from alcohol in pregnancy. So people are starting to catch on at this point. In terms of the biological mechanisms, Neil actually talks about this quite a bit in chapter 4, and I'm not a biologist, but I will just cover 2 of the key mechanisms here. So the first one is cell death. So you've probably heard the phrase "alcohol kills brain cells." And it's not just brain cells. Alcohol molecules cause damage to cells through several different mechanisms. One of these is called apoptosis, which is a normal part of growth where cells that are no longer needed die off and make way for those cells that are needed. Unfortunately, alcohol can disrupt this process and lead to too much apoptosis, so too much cell death. The other mechanism I'll mention is epigenetics. This is about a range of molecules that control gene expression. So every cell in your body has DNA, which can be thought of as like an instruction book for how to build and operate a cell. But it's the same book in every cell. So brain cells, for example, as well as containing the instructions for how to build a brain cell, also contain the instructions for how to build a skin cell and a kidney cell. Epigenetic markers are like someone went through the book with a highlighter saying, you read these bits. So in other words, they turn on or turn off different genes within that DNA molecule. Now, things in the environment can change the way these markers work. And so they can alter which genes are activated. And there's some evidence that prenatal alcohol exposure causes harm through this mechanism. So turning things off that should be on, turning things on that should be off. And these changes can actually be inherited by the next generation. So biological grandchildren can be affected by this. The good news on that, though, is that those changes, epigenetic changes, don't tend to go, they do tend to go back to normal, if you like, if the environment goes back to normal. So with no alcohol exposure in the following generation, those changes should no longer be present after sort of 2 or 3 generations. The final thing I'll talk about is some risk and protective factors. So things that increase the risk of FASD or which might make it worse, and things that prevent it or might keep it less severe. I mentioned earlier that maternal alcohol consumption is more impactful than paternal alcohol consumption. We saw that in the Sullivan study. And that's in terms of direct harm to the fetus. But that it does seem that dad's drinking can have an effect. It won't lead directly to FASD because that is necessarily caused by alcohol exposure in the womb. But there is some evidence from studies around IVF services that alcohol consumption in men can decrease sperm quality and sperm counts, leading to a lower chance of pregnancy and an increase in the risk of miscarriage. It's also the case that there is a substantial social influence of alcohol drinking, meaning that anyone whose partner is pregnant should, in my opinion at least, should be advised to stop drinking along with their partner for the duration of that pregnancy. There's many biological and chemical substances that and processes that affect the way alcohol can cause harm to the fetus. Again, I'm not a biologist, but this slide taken from a review shows how some of the genetic, biological, and environmental factors, including things like diet, are interrelated in a very complex way. They all affect each other. And it makes the pathway between prenatal alcohol exposure and the outcome in terms of severity of FASD very difficult to predict. And we still can't really say what level of harm is likely in any given pregnancy, even if we know the amount of alcohol consumed. And the final point I'll make in this today is if you couple this with the fact that some studies have shown an impact of prenatal alcohol even at low level exposure, that is why the best advice is to abstain from alcohol during pregnancy. That's all I've got for this. Obviously, there's a lot more detail in the chapter, but hopefully that's a useful overview.
That's fantastic, Alan. Thank you so much for covering, centuries of understanding in such a short period of time. I'm going to end the recording, but before I do, I just want to remind people that these videos are going up on YouTube, and there's also easy access summaries that we're doing of each of these sessions too, so that if people might not find necessarily the language even on our videos easy to access, we're trying to make this as widely available to as many people as possible. And that was part of what Raja and Neil hoped would come from this book club. But the book is available also if anybody would like to get the book, which has been written for practitioners. So the upcoming sessions on 16 September, we have Professor Anna Hanlon-Dearman from the University of Manitoba talking about how FASD presents across the lifespan. And on the 22nd of September, we have Professor Raja Mukherjee talking about the diagnosis of FASD and overlapping neurodevelopmental conditions, how that gets things even more complicated. So at this point, I'm going to say thank you to Alan, and I'll end the recording, but please stick around for the Q&A, everybody.